Hey there, folks. Welcome back to class. This is is my calendar's correct, this is the last day of September. And we are in, I believe, chapter 11. We're going to look at mountains today and mountain building. Um, this chapter has a couple very important points, but there's also an awful lot of information in there that I don't need you to be too concerned about, and I'll definitely go through and let you know what you need to pay attention to and what you can kind of glance over. You definitely need to read the whole chapter and try to understand the concepts and stuff they're talking about. But there's some stuff in here that we're not going to get into great detail, but there are a couple big ideas that we definitely need to look at. So let's go ahead and jump into the chapter here. Craig's cracks, crumbles, crustal deformation, and mountain building. So, mountains, as you can imagine, are very interesting things, and mountain ranges are as different as they are. Every single one of them is slightly different. So, mountains are interesting in that for a long time, geologists didn't know where mountains come from. I mean, until the idea of plate tectonics comes along, uh, how does number one, how does a mountain form? And number two, if we look around and see erosion and mountains being eroded, then if the earth is as old as we say it is or think it is, then how do mountains stay up? I mean, they should be all flat by now, right? If everything was eroded, everything should be flat by now. So mountains were kind of a mystery for quite a while until we started talking about plate tectonics, and then they fit nicely into the concept. And we'll look at that in a little bit more detail. Here you see a picture of a mountain range. We know about the Rocky Mountains out west, but we often don't think that those mountains go all the way to the south down into the Andes. So it's all part of the same system where you have the Pacific Plate pushing and grinding against the North American plate and the South American plate, and a couple little plates in between. And again, as we've already talked about with volcanoes and with earthquakes, especially, we see a lot of volcanic activity and earthquake activity along this line. So this idea of plates coming together and pushing up mountains, we see that here in our own country and don't realize it really is just a very small part of a very large range of mountains. So we call these mountain belts. And when you see them from the ground, they look like one thing. But if you look at them from the air or look at a map, they're pretty amazing things. You can see how, again, it's almost like a blanket that's been put on a table or a tablecloth, and you start to kind of push it, and you can see it ripple up, and it's almost exactly the same process. Your book calls this mountain belt origin, and you'll see that quite a bit in the book. I'm not going to use it. It's it's Greek words again, but it's just kind of a fancy word for building up mountains. So when you see the word orogeny, just remember they're talking about mountains. All right. So here is a map of the other half of the world, and we see mountains there as well. And again, most of them are caused by uplift of plate material, crust material, by plates coming together. You can almost look at, again, the plate boundaries and see where these mountains happen. Very few mountains, and again, there's also always a caveat that there's very few places where in the middle of a plate we'll see this kind of uplift. There you see the Tibetan Plateau. So these are the largest mountains in the world right here. That's where Mount Everest is located. And it's because India, and we're going to see this in a little bit, India is part of this Indian plate, has been moved and pushed up into the Asian plate. And again, your book will show you some really great maps of that in just a little bit. But let's talk about rock deformation. So, as we've already seen, rocks can behave in different ways depending on the type of rock and depending on the kind of pressure and the amount of pressure that's applied. So rocks can deform by breaking, bending, shortening, stretching, shearing. All these different things can happen to rocks. And you can imagine that if it happens to individual rocks on a small scale, it can happen on a large scale when we talk about mountains and the way mountains are formed. So, for example, here is the Matterhorn, a very famous mountain in the Swiss Alps, and it is in fact the joining place of two plates. You've got one plate crashing into another and literally sliding up on top of it. You've got the European plate and you've got the African plate coming together literally on this one mountain, where part of this plate is crashing up this way and part is coming up this way. And you can actually see the different types of rock in the different kinds of plate in this mountain range. Again, this is Southern Europe, Switzerland. So anyway, let's look at kind of how this happens. We've got really two different things that can happen. This crustal material, these rocks can behave in a brittle fashion, or they can behave in a plastic fashion. And again, when we say plastic, we're not talking about what the toy's made of, but we're talking about plastic in terms of a verb, the way something will deform. In other words, it will bend rather than break. When we talk about brittle, we're talking about things that when you bend them, they break, right? Like a dry stick. If you had a dead stick and a stick that came from a live tree that still had sap in it, if you bent the dead branch, it's very brittle. It's going to break very quickly. Whereas if you've got a branch that came from a live tree, it's got all that sap and stuff in it, still got water in it, it will bend and bend and bend and not break very cleanly. So that's same thing happens with rocks. So here's some examples of some brittle and some plastic deformation. So here you can see some sedimentary rock here, and the bands are all still nice and straight. Now what we're going to see is these can be uplifted straight up. They can be tilted. We see a lot of that here in Kentucky, where the crustal material has been broken somewhere, and the whole thing kind of tilts at an angle, and so it makes sort of a mountain, as you can imagine. But in fact, what's happening is the bands are going this way. So on this side of the mountain, you see a lot of broken rock and a lot of rubble. On this side of the mountain, you might see very flat, smooth rocks. Because it's part of the original band of material. Down here we see something that we don't see as much in Kentucky, but here we see the plastic bending of rock, where pressure and heat, and again, that sounds like metamorphosis, doesn't it? So a lot of these rocks are metamorphic in nature because of the forces that cause them. But here you can actually see the bend. So these lines used to be nice, smooth, sedimentary lines like this, but because of the pressure, the heat caused them to bend instead of breaking. We see plastic deformation. So what are some things that can happen? We already talked about temperature, where something maybe gets close to a pluton, place under the ground where we have molten material, and that might heat it up to the point where it becomes plastic rather than brittle. Here you can see the tilting that happens. Like I said, this happens quite a bit here in Kentucky. There you can see where things have tilted, right? You can get some deformation by these faults, and again, we'll talk about that briefly here in just a minute. But we can get things like deformation we can see this in sedimentary rock. Again, not metamorphic, it's still sedimentary, but it has been pushed and pulled and sheared into changing shape. So again, temperature could be part of this, pressure can be part of this, and literally just the weight of rock on top of rock can cause deformation. The rate of deformation can determine whether something bends. Like if you try to bend something slowly as opposed to quickly, it can cause it to bend or to break. And so all these are important concepts in how this works. And your book shows you a lot of great little pictures. So this is a good spot to look at how this sort of thing can happen. They go into discussion of force and stress. When we talk about forces, rocks can be pushed together, which can create stress. Pressure kind of comes from all areas. There you can see an example of pressure. When we talk about shear, we're talking about one part moving in one direction, one part moving in another, just like a pair of scissors. Scissors are often called shears because that's the way they cut. One blade is going one direction, one's going another, and it literally shears a piece of paper or fabric in half when you cut them with a pair of scissors. So those are the kinds of forces we see on a large scale when we talk about mountain building. So brittle structures, again, we see a lot of that here in Kentucky. And this looks very similar to areas where you have these outcroppings and they're broken off and pieces broken off of them. This is an example of some of this brittle um, deformation that's happening. Here you see what looks like little bitty mountains, but in fact what this is where the sediments have been turned literally 90 degrees. And so now they're literally sticking straight up in the air and being eroded. And so you get sort of this kind of a striped pattern, which is that rock literally turned sideways. And here we can see how some of that uplift can happen at different scales. Your book goes into talking about these faults, and again, like we were doing with earthquakes, I don't expect you to know all these different kinds of faults. Just understand that when we have a fault, we have a break in the crust, and one piece of the crust can go one direction, one can go another direction. And if you know what you're looking for when you see this on the surface, again, maybe you're hiking or you're looking at a mountain and you see this band of rock that kind of goes around that's exposed, that's probably a fault. It's probably a place where part of the crust maybe stayed still, the other parts kind of fell down. And so these could be literally fault lines that you might see rather than some sort of uplift. And again, we're not going to get into all the, I mean, definitely read this. It's the same, pretty much the same stuff you read when you were looking at earthquakes. And be aware that there are different kinds, but you don't have to worry. You don't have to memorize all these different types of faults. All right. So here's just some examples. You might see an outcrop of rock or a road cut that might expose some of this. So here you can see one layer, and then here you see the exact same layer down here. Well, at one time they were connected, and so there's the fault. There's where the two pieces have moved, the joint between them. And so your book shows, and you can see some of these, just again, by driving down the road, you can see some of these kinds of faults. It's pretty interesting. So again, we've are looking at folds and foliation. So this is the plastic kind of deformation. We've already talked about foliations, haven't we, when we talked about metamorphic rocks? So we would guess if we saw these kinds of folds and foliations in a mountain, we could almost guess that the rocks that we find there would not be quartz, but would probably be quartzite. Or we probably wouldn't find shale, we'd probably find slate. So we wouldn't find these sedimentary rocks that we might find in a different mountain, but in these, when we see folds and foliations, we would guess that in fact what we'd find are metamorphic rocks, and you would be correct. So here we can see some of those examples with pictures and also kind of cutaways as to how these folds can happen. And again, the forces are heat and pressure, which sound very much like the formation of metamorphic rocks. This is kind of an interesting little section because a lot of times you can see on the surface a particular pattern in the rock or in a particular hill or mountain, and not understand until you actually go in and look at the rocks that these rocks are the same as these rocks, right? And then you understand what's happening under the ground. A lot of geology is based on this idea because in a lot of these areas you can trap things like coal and gas and oil. And so a lot of geologists, if you do become a geologist, a lot of them get jobs with the oil and gas companies because they send geologists out into the landscape somewhere looking for these kinds of clues, letting them know what's happening underground and where there might be, for example, in an area like this, you might have gas pockets trapped. And we'll talk a little bit more about that when we get into resources. But anyway, this is a good example of being able to see what's happening on the surface and guessing and being pretty correct about what's happening below. Again, here's some more of that folding. Sometimes it happens in very subtle ways, and sometimes it happens very dramatically. Again, these are kind of the basic ideas. Your book goes into a lot more detail than I need you to do, but I need you to understand those two basic ideas: the idea of things being brittle or things being plastic, and understanding the difference between the two, and how those rocks behave. Um, so tectonic foliation, whenever we talk about tectonic, we're talking about, of course, plate tectonics and the way plates move, and these forces are generated through that kind of movement. So it really takes that much force to do this kind of bending and this kind of breaking. You're talking about an entire mountain being broken, or an entire mountain being lifted up and bent. And so your book starts to talk here about causes. And of course, plate tectonics is going to play the main role. Mountains can be related to subduction. As you remember, subduction is where we have plates. One plate is moving under another plate. That can cause volcanoes, which are kinds of mountains and kind of ranges of volcanoes. It can also cause uplift. So as it's moving under another plate, it can cause that plate to kind of buckle and move up. And that can happen in lots of kind of weird ways. One article I was reading just recently about the formation of the Grand Canyon in that plateau was from subduction that actually went down, then came back up and pushed this large section of earth up a couple miles, and then back down. So it can be quite traumatic. So here's an example of that subduction and how it can things can kind of pile up and push up mountains, as well as volcanic and earthquakes. So a lot of times, though, mountains are created by continents colliding into each other. So if subduction is because I have a more dense plate diving under a less dense plate, what happens when the densities of the two plates are about the same? Well, that's when you get sort of a car crash, don't you? You get two plates crashing into each other, and you get mountains built in that way. So your book talks about how the Himalayan mountains have been formed. Here's India, the Indian plate moving and crashing into the Asian plate and causing that ripple. Again, you can almost copy it by taking a rug in your house and kind of pushing on one end of it and watching it bulge up in the middle. And that's exactly what's happening here with the plates. You get this balding up and get mountains. Here's what is happening with India. India at one time was an island, but now it's part of Asia, South Asia, and causing. So these mountains, this plate is still moving, isn't it? This plate is still crashing in. So the Himalayan mountains literally are still getting bigger. If you climbed the Himalayan mountains last year and climb again this year, you'd have to climb about 1.5 inches to 2 inches higher. Wouldn't you? Than you did the year before, which of course you wouldn't, sure you wouldn't be able to notice, but that's what's happening geologically, right? Again, we've talked about volcanoes a little bit. Your book goes into that. Continental rifting is where, again, as you remember, plates are moving apart, and so this moving apart can create these blocks of material. And mountains, not very big mountains, but it can still cause some mountain building to take place. Let's see here. Your book asks the question, why are mountains so high? And so it's an idea of thinking about mountains. Remember that these plates are sort of floating blocks of rock, which still sounds kind of weird, but they are still floating. And so as a mountain is being built, not only is it being built up at the top, it's also being built up at the bottom. So here we can see where as these plates crash together, there's also material being formed down here at the bottom. So the whole thing acts sort of like a big buoyant bobber, right? I mean, as this builds up down here, this wants to float even higher. And so mountains get high literally because they're being, from the standpoint of buoyancy, and again, this sounds kind of weird because we're not talking about water, we're talking about molten material, right, in the asthenosphere. But buoyancy happens whether something is very heavy or very light. So if something is less dense than something else, it's going to be more buoyant. It's going to float on top, and it's going to get pushed up by the more dense material. And that's what's happening with mountain building. So mountains are not only tall at the top, they're also very thick at the bottom. That's what's actually causing them to get pushed up. It's a pretty important idea to think about. Let's see here if there's anything else super important in this section. Go ahead and read it. Definitely here we start talking about, again, mountains rising, but also mountains coming down in terms of erosion. So as you can imagine, as a mountain is eroding, it's releasing pressure and looks very different. So here are some mountains in Switzerland, right, carved by glaciers, and fairly new mountains. You can see how pointed and there's not a lot of erosion that's happened. But look over here at some mountains in Brazil. These mountains used to look like these mountains, but now you can see quite a bit of erosion happening. You can imagine two mountain ranges in the United States and almost guess by looking at two pictures of them which mountain range is newer than the other. One of the last sections here talks about basins, domes, and cratons. So when we talk about a craton, we're talking about a place that hasn't seen any mountain building, hasn't seen these forces. And so the material there is relatively unchanged. And there are some very big places on the planet, as you can see here, even in our own country, where we have these large areas that have not experienced any mountain building. And in fact, we live in one, at least part of our state does. The eastern part of our state is in the Appalachians, but where we live in what we call the bluegrass, we live in one of these cratons where there has not been, over quite a bit of time, some mountain building taking place. Your book talks about the Appalachian Mountains. So this is a really great story. This is really amazing because they are close to us, and if you've ever driven out east, you've been in these mountains. So they are important. It's amazing how old they are. I mean, this story, as the thing says here, the story began over 1 billion years ago. So this whole creation, and this was long before there was even a Pangea, right? So the Appalachian Mountains have been here a very long time, and the process that formed them has happened over literally almost 1 billion years. So they are very old mountains. There's some very old rocks in the Appalachians, and it's really a cool place to go if you like rocks, if you like to explore that. It's a really cool place to go. Again, I was talking about it's one thing to see it in one way, but then to look at it from the air. If you've ever gotten a chance to fly in an airplane over the Appalachians, or even better, flown in a private airplane where you're not quite so high, it's incredible to see the folding of these mountains and the pattern that they make. It's really a pretty cool thing. So that's about it with mountain building. Here are some review questions you can work on if you want to, and I will get back with you on I guess we're going to look at section E here on the next lecture.